Welcome back. In this video, I'm just going to do a couple examples of this style of question. So in this question, what I'm asking is to find a value of the constant c so that the average rate of change of x squared on the interval minus 3 to c is equal to 4. So how are we going to do that? Well, we're going to write down a formula for the average rate of change on this. So remember, the average rate of change on the interval is going to be f of c minus f of minus 3 divided by c minus minus 3. All I did here was to remember that the average rate of change is the change in the output over the change in the input. Here I have to use the fact that the function's x squared, so f of c is c squared, f of minus 3 is 9, and c minus minus 3 is c plus 3. Okay, I'm going to go ahead and notice I can simplify this. Namely, if I factor the numerator here, c minus 3 times c plus 3 divided by c plus 3. And once I've done that, I can cancel the c plus 3's. And so the average rate of change of this function on this interval is c minus 3. And what was I asked? I was asked what c will make this average rate of change 4. So to answer that question, I will take c minus 3 and set it equal to 4, and so I will find c equals 7. If you want to check your answer here, you can find the average rate of change of f of x equals x squared on the interval from minus 3 to 7 and make sure it works. Okay. So this should be minus f of minus 3 divided by 7 minus minus 3, which is 49 minus 9 divided by 10, which is 40 over 10, which, lo and behold, is 4. Okay. Note that just checks our answer because we wanted this to be 4. Okay, and so we have found that, yes, the average rate of change of x squared on the interval from minus 3 to 7, it's 4. Okay, so here's a little variation on the same question. We now want a value of c so that the average rate of change of this function on the interval 1/2 to c is equal to minus 2. Okay. The only difference here is that now our function is 1 over x instead of before where it was x squared. So let's write down our average rate of change. It is going to be g of c minus g of 1/2 divided by c minus 1/2, which is going to be 1 over c minus 1 over 1/2 divided by c minus 1/2. 1 over 1/2 is 2, so this is 1 over c minus 2 divided by c minus 1/2. And I'm going to go ahead and put this over a common denominator now. So this is 2c minus 1 divided by 2. Okay, that's because c is 2c over 2. I'll now put the numerator also over a common denominator. So that will be 1 minus 2c over c. Okay, and now I have fractions on top of fractions, so I can clear that by multiplying by the reciprocal. And now I should notice, hey, 1 minus 2c and 2c minus 1 are almost the same thing. The only difference is that they've been flipped. And so here I want to note a particular algebra rule that you may not have thought about before, which is that a minus b is the same thing as negative b minus a. So if you change the order on a subtraction, all it does is put in a negative sign. So I'm going to do that here. Namely, I'm going to rewrite 1 minus 2c as minus 2c minus 1. And why is that an improvement? Because now I have a 2c minus 1 in the numerator and a 2c minus 1 in the denominator, and I can cleanly cancel those to get that the average rate of change of g of x on the interval 1/2 c is minus 2 over c. And then what do we need? We need to solve for when the average rate of change is equal to minus 2. Well, this is our average rate of change. So I need to solve the equation minus 2 equals minus 2 over c. I will multiply both sides by c, so that will give me minus 2c equals minus 2. And then I'll divide both sides by minus 2, so I will get that c is 1. Again, if you want to check, you can check that the slope of the line from 1/2 comma 2 to 1 comma 1 is exactly equal to minus 2. But that's it for 2.1. In the next video, we're going to start talking about limits, which are going to be the topic of all of Chapter 2, and which we sort of teased at here at the very end of this section. But for now, I'll see you next time.